All right, so we talked a little bit about the graphs of exponential functions. We're going to talk about them now in more detail. Combine a lot of things from previous sections: domain, range, intercepts, transformations. Lots of good stuff is all coming together in chapter 6. Chapter 6 is the big finish, especially the end of chapter 6. The finish of the finish. So let's do a little remembering. For y equals a times b to the x, this is 6.1. It looks like, well, if b is bigger than 1, it'll be growth. If b is less than 1, it'll be decay. In our little picture, let's just say we're looking at growth. What do we have for something of this form? We know the y-intercept, right? We know the domain. We know the range. We know the y-intercept. We know something about the x-intercept. We know something about asymptotes. All these things we know. The domain of any exponential function, that's all the x values, right? If you kind of zook this graph, that's not a real word, but drag this graph to the x-axis, right? It covers the entire x-axis. That's the domain. The domain, this red line, is all real numbers. Okay? Negative infinity to positive infinity. But the range, right, if we drag the graph to the y-axis, the range, we never hit 0, but we do get all positive values of y. So the range is going to be 0 to infinity. The y-intercept, a was the starting value, b was the growth or the decay factor. The y-intercept is always that starting value when x is 0 and y is a. If you forget, remember that the y-intercept is just the point where x equals 0, and you can solve. And the x-intercept is the point when y equals 0. Where do we cross the x-axis? Where do we cross here? We never cross the x-axis. So there's no x-intercept unless we do some function transformations, right? If we moved this whole thing, move this whole thing down, then yeah, we'll cross the x-axis then. The asymptotes are at y equals 0. There's only one asymptote. Asymptote. Okay. And again, we could really tie things together. Asymptote, what does this mean? This means as x goes to negative infinity, y, or f of x, is approaching 0. Specifically, it's approaching 0 from above, from the right. All right. And again, we could have also had said the limit as x approaches negative infinity of this function is 0. These are other ways of seeing this asymptotic behavior. Remembering back to 5.6. All right, so that's basically what we have right here. All of these are affected with function transformations. Okay, function transformations affect these. Nope. Affect these. After the great principal debacle of 6.1, I gotta get my spelling right. So if we have any function transformations, these might change, but this is our starting point. Let's see what that looks like. Let's put it all together. Example 1. The graph. Oh, the sun came out. Nice. The graph of f of x equals 1/2 to the negative x is reflected about the y-axis. It's also compressed vertically. Oh yeah, function transformations everywhere. By 1/5, and it's shifted down 2. Part A is what is its new equation? After all of these things happen to it. Well, let's call it g of x. Let's do things one at a time. Remember, we do horizontal shifts first, vertical shifts last, usually. It's a good rule of thumb. And everything else in the middle. So that vertical shift last is the only thing that's really going to come into play here. So this is where we started. 1/2 the negative x. First, it's reflected about the y-axis. Y-axis is here. They're reflected across here. That's a horizontal change, reflecting it from right to left and left to right. Horizontal changes are on the inside of the function. All right, but here, the inside is not actually the parentheses here. The inside is always where x is. So we're putting a negative right here. This becomes positive x. When we say inside of the function, that means where x is. A lot of times it's inside parentheses, but here it's not. Watch out for that. Again, if you make your b value negative, you run into some real wacky stuff. So we've done that first part. Oh no, there we go. This is now positive x. Next, compress vertically by 1/5. Vertical changes are on the outside of the function. This is going to be multiplying by 1/5 on the outside of the function. Oh, we have a new a value. Our starting value used to be 1. Now it's 1/5. We're also going down 2. Vertical change outside of the function. Subtract 2 at the end. So it turns out that all of these things get changed as well. Vertical changes affect y things. So the vertical changes are going to affect these 3. The horizontal changes are going to affect the other 2. Okay. Oh, this is also related to a vertical change. But the fact of the matter is, I'm okay with you guys graphing this on Desmos. Okay. So let's do that. Get a visualization here. This is going to be y equals 1/5 times 1/2 raised to the x minus 2. This is what it's looking like. So notice how we used to, bless me, I have to bless myself because you guys will be blessing me in the future and I need the blessing now, I think. The asymptote used to be at y equals 0. Now the asymptote got moved down 2, right? It's at y equals -2 now. All right, and so on. What's the domain of this? What is the question asking? We don't have a question yet. This is the answer to part A. Let's go to part B. This is why I need that bless me now. Part B is saying find the y-intercept, the domain, and the range. So we can find the y-intercept graphically. It's where it crosses the y-axis, -1.8. Or you can find it analytically. Y-intercept is when x is 0. G of 0 is going to be 1/5 times 1/2 to the 0 minus 2. Remember, any non-zero number to the 0th power is 1. So this just becomes 1/5 minus 2. Either way, the y-intercept is at -1.8. Domain of any exponential function is always all real numbers. Look at all the x values here. We can have any, there's every x value is represented somewhere on this graph. Every x value is represented. All real numbers. The range is not though, right? We had that asymptote. There's nothing that hits this line and there's nothing below this line, the y values, the range, the set of all y values is only things above 2. Okay. Our range here is only things above, negative 2. That's how we solve these sorts of problems. Part C. What is the asymptote? For exponential functions, as soon as we know the range, we know the asymptote. Because the asymptote is always at the edge of the range. For exponential functions. So if the range is everything above -2, the asymptote has to be at -2. And it's a horizontal line, so it's y equals. Horizontal line, it's y equals right here. That's our horizontal asymptote. All right, let's do one more example. Example 2. Graph and do the same thing. Find the y-intercept, the domain, the range, and the asymptote. So I'm going to do a little hybrid, similar to what we've done a little bit before. I'm okay with you using Desmos, but I also need you to graph it manually as well. Being able to get the relevant information from Desmos and putting it on your own graph is really, really important. And again, our function here is going to be -2 to the x plus 1. All right. So let's get our coordinate plane and let's graph it. -2 to the x plus 1 looks like this. So right off the bat, one of the easiest ways to graph an exponential function is if you know the asymptote. Well, if we look at the function, we should expect the asymptote to be y equals 1. Let's plot it and see if it looks right. Y equals 1 looks like that. That's our asymptote. That's where we're going to start on our graph. Give a nice little asymptote at 1. Now let's plot some points. Plot some points that are on the graph. The point 0, 0 is on the graph. Let's plot that. What's another point on this graph? The point 2, -3 is on the graph. Where are we at 1? When x is equal to +1? Is that -1 exactly? Yes, it is. +1, -1. Let's get some on the left too. And to do that, we're going to look at the growth factor, 2. This says every time we move 1 unit to the right, we double. Normally we double, but here we're going to double the distance from the asymptote. This point is 1 away from the asymptote. This is 2 away from the asymptote. And this is 4 away from the asymptote. The next one should be 8 away from the asymptote. All right. So utilizing this pattern, and we can check this on the graph, we should be at 1/2 here, at 3/4 here, and so on. When x is -1, we should be at 1/2. Get these points from the graph and graph these points on your paper. And once you have quite a few points, now we can sketch the graph on our own paper. And it should look like that. The y-intercept, where does it cross the y-axis? At the origin, 0, 0. The domain of any exponential function is all real numbers. The range, well, the biggest we can get is at +1, but we never touch it. The smallest our y values can get is -infinity. And the asymptote is always at the edge of the range. This number and this number should always be the same. It might be on one side or the other, though, of the range. We have our graph, we have our answers, and that's how you do these problems. You can use Desmos, but make sure to include the points. Make sure to include the scale if it's different than 1. So, right, our scale here is just we're counting by 1. If you don't write that, I'll just assume that you're counting by 1. But if you're counting by more than 1, you have to write it down. Let me know if you have any questions, and good luck.